This video handles about vertical shrinking again, and in this case we look at the coefficient again of the cos theta, which is a quarter. So it means that each and every y value we will multiply that by 4, or we take a value divided by 4. So in this case we take 1 divided by 4, which gives us a quarter, and 0 divided by 4 is still 0, and then if I look at minus 1 divided by 4, I will get negative a quarter there, and so on. So we have our dots at J and B and K and D and L and F, so we're just going to join it on the next page. So the idea is just to see that this coefficient here in front of the cos theta vertically shrink this graph, so it makes all the y values a quarter smaller. Let us run through the properties of this graph, the red graph here, and we see it's much flatter than the other graph. It's literally squeezed vertically down to maximums of quarter and minimums of negative a quarter. So the period, you can easily see, is exactly the same. It's 360 degrees. The amplitude is the coefficient here of quarter, and the roots, if we look at the roots of a quarter cos theta equal to 0, we get exactly the same roots as when we take the roots of cos theta equal to 0, which we have discussed previously, and we know the roots of that, or all the odd numbers, times 90 degrees, where k is an element of z. Verify that you are able to get to that solutions, and you can quickly test your answer by substituting values for k, like k equal to 0 will give you 90 degrees, k equal to 1 will give you 270 degrees, etc., etc. The extremes are now plus a quarter and minus a quarter, and they occurs here at there's a J and a K and a L and the M and N, etc. So all the minima, we will find that we can again write down any minimum value. So let us write down the value at 180, or the one at K, which is minus 180 degrees. So my theta is equal to that plus K times 360 degrees, where K is an element of Z. And the maxima there we have at 0, and you can again write this formula like before. So in the end we can write it either as 2k minus 1 or 2k plus 1 times 180 degrees. The maxima will occur at 0 plus 360 degrees times k for k element of z, and in general we will have theta equal to 2k times 180 degrees, where k is an element of z. So on the next page we will just find a summary of what we've done here. So in this page you can see a summary again, just neatly typed out, and you can check whether you agree with everything that's written here. We can also write the minima and maxima as decimal numbers, and depending on what you prefer, but it's the same thing. And in this case I've left out the formula of the minima, which we saw is theta 2k plus 1 times 180 degrees, we case an element of Z, and 2k times 180 degrees, we case an element of Z. You can verify whether you agree with this, and I just made a note here. We've already done this on the previous page. We've already solved a quarter cos theta equal to 0 by solving cos theta equal to 0. Again, I want to emphasize, do not memorize this. Make sure you understand the concepts behind this. Whether you know that this quarter in front of the cos theta, that is what you are dealing with now. You're dealing with the A value, and we always want that to be positive for the stretching, so we will not have, for instance, a quarter cos x and say it stretch negative a quarter by a factor of negative a quarter. It's stretched by positive factor of quarter, and if you have a negative, then we will also mirror it in the one of the axes.